Well, all right. So rate of change is change in y over change in x, right? That's what the little triangle means. It's a Greek letter, delta. Delta means change. So f of x and 2 minus f of x of 1, right? Over x2 minus x1. Guys, we have not, honestly, you have not seen it written like this, right? You haven't seen it. It's more normally been like this, right? Right? Okay. F of x is the same as what? Y. So don't let that crazy notation scare you. You understand? Don't let it get you. Okay. We're going to calculate the rate of change looking at different points and stuff like that. We'll look at local minima and local maximas. We're going to look to see where things are increasing and where things are decreasing. Okay. I'm not sure. Okay, so they're doing, sometimes they'll go local minima or local maximum, which is local minimum and local maxima, and they talk about global, right? Have y'all heard that term, global? They'll use absolute here. Absolute and global are the same terms, right? So you may have been taught global maximum or global minimum, right? It's the absolute for here. So the locals are more or less, let's talk about it like this. Y'all have been to the mountains? Yeah, you're looking out through there, and it's pretty, isn't it? And you see little hills that just keep doing like that, right? They going up and down, and then you get way up there. You've been on the peak, like the highest peak. Was it Cleveland's Dome? Isn't that the highest point? Yeah, right. You can see, I don't know, 7 states, right? Isn't that what they say? Yeah, 5 or 6, something like that. It's crazy. Yeah, a whole bunch, right, from that high. So that's a high point, right? That'd be like an absolute, right? Because if you look left and right, you ain't seeing no more mountains, right? But these locals, you kind of like, you down in here, you kind of, and you be like, oh, there's a mountain up there. Oh, there's a mountain up there, right? They're just little mountains, but they're not the highest mountain. How's that? That's what a local is. And local minimum is, it's a valley, but it ain't the lowest valley. It ain't the lowest output, the lowest Y value. Okay? An absolute would be the lowest point in that particular function. That's the difference between those. And we'll see it. Don't worry. All right, so we're going to start out. We're going to look at the average rate of change on this function on the interval specified. Now, I'm going to tell you, guys, these are x's. How do I know they're x's? See that word? Interval. Interval notation. So here we go. You're basically creating a t-table, guys. So you're going to evaluate it when it's -1, and you're also going to evaluate it when it's what? +1. So that's 5 minus 2, which is what? 3, and then what? So I got 3 and 3, correct? Yeah, I just plugged them in, right? Y'all agree with my calculations? Yeah. So if I look at the average rate of change, then I can look at it in terms of this. Y2 minus Y1 over X2 minus X1. So I can do 3 minus 3. Let's say this is group 2 and this is group 1. Is that okay? And then that would be, and then it would be what? 1 minus minus 1, which gives me a what? Plus, so that's 0 over what? 2. Y'all agree? Yes or no? I just plugged it into the equation. Excuse me, into the equation. I think what I showed you the other day was do change in x and change in y. That's what? Positive 2, and this is what? 0. So slope is changing y over changing x, which is 0 over 2, which is nothing more than what? 0. What does that equate to? What type of line are we looking at? Huh? Horizontal. Because look who ain't changing. Who ain't changing? No. The y's. You're right. It's okay. The y's not changing. So if the y's aren't changing, that's a horizontal line, right? And anytime you have a change in either your x or your y to be a 0, then you've got a special case. You've either got a horizontal line or you got a vertical line. That's a dead giveaway. If there's no change in one particular coordinate, then you're looking at that. So the slope is 0. Okay. You've got parts over whole. So you have no shaded parts over 2 to choose from, right? Y'all remember the pizzas way back when? Yeah. Okay. Good? 0. Yeah. They're just saying for this interval, find the rate of change. And it's quadratic. So I know that, that it's going to come down. But they're only picking 2 points and connecting as though it's a straight line. That's the thing you have to make sure you worry about. All right. So if we can do it on an equation, we can do it on tables. So between 2002 and 2003, that's one. How much is this? There's you changing y, and there's you changing what? Because slope is changing y over changing x, and that's 2 over 1, which is what? 2. Y'all agree? No, ma'am, I didn't pick 2. How far is it from 249 to 251? 2. Yeah. And now they want us to go from 2002 to 2005, right? So how far is it from 2002 to 2005? That's how much? 3. And then they want us to go here, right? So how far is it from 249 to 243? -6. Why -6? It went down, right? You're going down the number line. So therefore, if we look at this one, we're looking at changing y over changing x. That is -6 over 3, which is negative what? -2, right? You could plug them into the equation, the formula, if you want to. That's fine. I just find it easier to look at the change. How's it moving? And then you're good. If it's going up the number line, if it's increasing, it's positive. If it's decreasing, then it's negative, right? For that particular value. And you always have to look and make sure that your signs are taken care of. Because you have a negative or negative, which is a positive, right? Yeah. What you got?
What's confusing for me is which one's the X and Y?
Left side's X and right side is Y.
Always.
Yeah. For tables, yeah. Yeah. If you remember the T-tables that you used to create, you'd put the X on the left and Y's on the right. Yeah. So that when you look at a table like this, it's the same thing. Yeah. It's just not going to say these are the X. It's understood that time is always an input, and that's a year, right? So the output's based on the year. All right, guys.